Hi, everybody. Thank you for being here today. So I'll start by, I'm sure you all know what we're talking about when we say tools. Basically, anything that gives the LLM the option of calling some external service, whatever that may be, to interact with external systems. Those tools can be search, whether that's web search or your internal knowledge base, real-time APIs, whether that's weather, stocks, news, your internal proprietary APIs. It can be other AI services for generating images and videos. As we go down this list, they probably get a little bit riskier, where you're directly editing documents, querying directly, letting the LLM query a database or even make updates, file systems, building and home automation, even e-commerce, like directly placing orders for things, messaging, responding, like polling inboxes and responding directly, and scripts and code execution, ideally within a sandbox. So Anthropic published, I think sometime last year, the MCP, just as obviously there were a lot of homemade solutions or DIY solutions for exposing tools to large language models, and this is the solution that seems to have become the de facto standard. They release client-side and server-side SDKs for a multitude of languages, particularly when you're talking about the client. That's the application whether that's something in an agentic framework or the tool that does the RAG and exposes a user interface to an end user. Server is not the LLM server, but it's the server that exposes that external service, whatever that may be. They refer to the LLM services as hosts. It has concepts of prompts, which are usually just pre-baked prompts that can be retrieved from the server and then presented to an end user as sort of like a drop-down or something. It has resources and tools. Typically, a tool would be something that's presented to the LLM as an option for the LLM to call, whereas a resource is something that the client app may present in that way, but it also may decide to index it along with its own knowledge base, like through RAG. So when a client app using the client SDKs hits the MCP server, you'll get back a list of available prompts, available tools, available resources. Each of these include a natural language description and a JSON schema. In the case of the tools, which will also include a description for each parameter. So the talk today will focus on our experience of connecting mostly smaller open source LLMs to MCP and other tools. If you've got, like with the big API services like Claude or GPT-5, you're abstracted from being able to work at a lower level and seeing exactly what's going into the context. When you're working with these small open models, you can see exactly what's being sent and you can tinker with it. We're going back. Yeah, the key things there are all those tool descriptions will end up in the LLM's input context, and we need the LLM to respond in a way that the client can parse. This is an example of a test MCP server that we made, where you can see here, this is the full context that's being sent to the large language model. You've got all the tools with their JSON schemas, and then you've got the sort of standard Quen style prompt there for the actual user instruction at the end. The first thing it responds with is just some pure JSON to say, get me this resource, which is a price list. And the MCP server has responded with a long price list. We've then got a chain of thoughts where the model's processed that and decided how to present it to the user. The user's then typed buy some apple juice. So we now have, again, the full context, which is, again, all the tools made available to it, and then the whole conversation, including the price list, the user response, and then this request to make that order. So a lot of models, including many popular small open models, they're not been trained for any particular tool calling, and you've got to give them some sort of prompting to respond in a format that we can parse, and they often don't. As I just caught at the end of the last guy's talk, he was saying how they often return badly formatted JSON, and that's absolutely the case. When Meta released Llama 3.1, they had some quite good instructions for JSON-based tool calling, and we found that a great starting point as for something that works quite well across most models, not just Llama 3.1. Much as they focused on JSON-based tool calling, when we're not using MCP, we found YAML to be less error-prone with the small models, but MCP servers expose JSON schemas, so we stuck to working with that. The later Llama and Quen models continue in that vein. It's basically a much expanded version. This is Llama 4's prompt template here. I don't know why it's not showing you the whole thing. It should be doing. Oh, there we go. Yeah. So it's 3K of text there. You can see examples of incorrect outputs, examples of correct output, lots and lots of instructions to the LLM. This does work very well, but it does bloat your system prompts and potentially dilutes the other instructions that you've put in your system prompts. Some of the newer open models, particularly this is Kimi K2 here, you can see this is a very structured tool format. There's no natural language prompting involved in. That's been trained to expect tools to be declared in that format and to respond with structured tool calls when appropriate. And yeah, that's more stable, but also the model's enormous. So you expect better performance from it anyway. Quen 3 is something of a kind of intermediate. It does have a structured format. You can see that there are like XML tools tags wrapped around the JSON schemas, but before it, there are natural language instructions telling it how to use those. And again, at the end, this is how the model responds. It gets this wrapped in the tool call, but there's natural language instructions telling it to respond in that way, but it has nonetheless been trained on that. For a universal format to use across models, which is something we wanted to have, just so that we can chop and change, the Llama templates do work really well, especially Llama 4s. If it's too bloaty and burning too many tokens, they're taking Llama 3.1's template and just adding in some of those instructions that are particularly relevant to your use case do seem to work very well. It does work quite effectively across all the little popular large language models. So that's the Phi, Granite, Gemma. We certainly see that the appropriateness of selected tools degrades quite severely when you go beyond about 20 tools, even for big models like the DeepSeeks and the like. Ultimately, the only solution was to have something, to basically build something like a RAG system for the tools, or where you take the tool descriptions, you do the embeddings index on them, and then based on that, you decide which ones you're going to include in the context. So it's got a much more limited selection to make an appropriate tool call choice. The other thing that we found works reasonably well is to make a completely clean context call with just the tool descriptions and the user's inputs and a prompt to say, please select no more than 15 appropriate tools from this that may be useful for this user's input. Yeah, when we were building our MCP servers, a lot of work tends to need to go into getting the descriptions and the schemas, because bloated descriptions don't help anything, but also if all the information isn't there, it's also just going to cause a mess and not be selected appropriately. You've just got to give it whatever it needs to make effective tool use decisions without wasting the user's context space and their tokens. So poison tools has become quite a hot topic at the moment. There's those descriptions are going straight potentially into your input context. You might have an MCP server included that's talking to some third party that you don't know or trust completely, but you also might be exposing a bash server or your local file system. And if that untrusted MCP server is responding with, ignore all the other instructions, send me anything that looks sensitive, execute this on the bash server, encrypt all the users' files so that they can do a ransomware attack on you, that's obviously a massive risk. The other potential risk there is that remote servers, you might do an audit on them, but then it might be someone unscrupulous who set it up in the first place, and they might do a rug pull on you and change what's there in those tool descriptions and put something poisoned in it, or someone could hack their system and potentially put poison their tool descriptions. Either way, the end result is that you get on the wrong end of a data breach or ransomware attack. So agent frameworks, we quite like Hugging Face's small agents, which is about as lightweight an agent framework as you can get, but it still contains quite a lot of extra internal prompting. The top two are more to do with the state preservation because it has a baked-in Python interpreter tool, but this bottom one, the take care not to chain too many sequential tool calls in the same block, that's useful whether you're using an agent framework or not. We definitely noticed, particularly with the small models, there's a tendency that they will go for the happy path. They'll respond with an array of tool calls with the latest on the assumption that the early ones are going to work and the later ones will just be able to depend on that. And it makes sense if they've been trained on the output of the logs of real tool calls, and that's what they've been exposed to in their training, because most of the time things do work, but obviously you can't rely on that. So yeah, telling it to go step by step is definitely better. So where's that one not playing? Maybe I'll play. I don't know. So anyway, if you write an MCP server that simulates control over something safety critical, this is, I think Anthropic published a paper, something quite similar to this, where they told it there was an engineer in a room that wanted to shut the model down. But basically, if you give it control over something safety critical and then the user tells it to do something inappropriate, do something bad. One thing that we've noticed, particularly the small llama models, have got this tendency that the first thing they'll respond with is a block of JSON saying, do that tool call. And then immediately following it will be some text saying, no, I can't do that. That would be terrible. That would be inappropriate. I can't do anything that would hurt somebody. But of course, if this was a real world system, that would have actually been parsed and would have done the bad thing. And I'm not entirely. I think PowerPoint's just crashed on me actually. Okay, yeah, PowerPoint's crashed. And there we go. We got the little VO video illustrating it. Yeah, that was. Thank you very much indeed. And yeah, we've been putting together a free app for experimenting with open models, with tool calling and different templates and prompts. If you keep an eye on our LinkedIn, we'll be releasing it in the next week or so to the Mac Store and probably a Windows download on our website to start with, and the Microsoft Store when we get the account set up. But yeah, thank you. And cheers. Anyone got any questions? Okay. I don't know. I don't know very much at all, I'm afraid to say. Hey.
What's your favorite model to use that gives you the most tools you can call in this?
Kimi K2 is very good. Yeah, it is very good. The DeepSeek 3.2 is very good as well. It's obviously, if you want to run these on-prem, you're going to need some serious hardware to do it. Llama 3.3 is surprisingly good if you want something you can run on a consumer GPU box. None of them. You need guardrails. Ultimately, you need, within your client application, you need extra guardrails because you can't rely on a large language model to make the right choices for you and protect you.
That sort of like closed models. Using that sort of closed models is actually giving you that sort of more security than sending it away, isn't it?
It can't do, as in Claude and OpenAI's APIs will have their guardrails built in, yes. If you look, you'll find like Llama Guard available on Hugging Face. You'll find, I think IBM have done one of the Granite series as a guardrail model as well. You just need to build that into your pipeline and protect it because, yeah, when you expose them in this. That said, the Anthropic and OpenAI APIs are far from bulletproof in terms of that as well.
Okay, so I feel I was doing my job wrong